Kindly unmute and speak.
And I think, Mr. Mulala, you can also be. We can also be putting the recorded lesson in the whether in the Google Classroom or somewhere. We can just put.
In the Google Classroom.
Yeah, we can also put it there. I'll also try to record mine. I can also put in the YouTube. We can see. People can still be able to reach it from there. It's going to be okay for us. Good.
Okay,
so,
Siaya, Marion.
The chair was saying.
Yeah.
The color of I'm saying that the color of the ion 3 ions is yellow. The only problem is the teacher's hands are brown and they are reflecting in that tin.
Whatever they are.
It is yellow, but the only problem was your hands are brown and they're reflecting.
Oh.
The color of your hands were reflecting.
So this one, reflect to us. Okay, so but now unaona vizuri without a reflection?
Yeah, it's yellow now, but the other time you carried it in a manner that your colors were the color of your hands were reflecting.
Thank you, very dangerous. You are a real scientist. You are magnetic real scientist. So that is but at least the power to be able to do that. That's good. So that
okay,
at least you're able to understand from there. Now,
Mr.
We can start.
Mr. Lucas, I think I'm going to mute everyone. Now. I think I'm going to mute everyone. Kindly unmute yourself, Mr. Unmute Mr. Maluka kindly. Mr. Maluka, unmute.
You have muted me. Sikuwa najua.
Okay.
So we can start now?
Okay, now you can continue.
Okay. So, students, welcome back again to our lesson today. Welcome back to our lesson today. We are dealing with the analysis of the organic chemistry 2. The organic chemistry 2. We're in week 7. The subtopic is polymers. In form 3, you did about the addition polymers. So today, I'm just going to review a little bit. And then I go to condensation polymers, which is a little bit tricky to most of the students. And so I'll be able to try to demystify and unpack the concept behind the formation of condensation polymers. As usual, we are joined with Mr. Mulala and Madam Ruth. So welcome to our today's lesson, whereby we are going to give you, or rather to provide you with the most distilled content that is there. Some of the questions you can post for them in the chat. Walimu watajaribu kujibu, unless ile swali tunaona ni common, then I'll be able to come up with it. So welcome. The topic is organic chemistry. The topic is organic chemistry. We are going to deal with addition polymers, condensation polymers, and we'll also be able to look at the uses of these particular polymers. So we look at the specific objectives. By the end of the lesson, you should be able to define the term polymer, draw and name the monomers, draw and name the monomers, and draw the structure of terylene and nylon 6,6. That is the syllabus for condensation polymers, and state the uses of some of the polymers, including the synthetic polymers that you learned in Form 3. Take a screenshot, but now we are now going to the content. We look at the review of the exercise that we did, that the question that we had done from there, and because now we cannot be able to, you cannot show the drawing, you cannot name the drawing on the chart. Maybe we can get the answers for what is the name of the group of compounds to which Z belongs. When organic compound Y is reacted with with sodium carbonate, it produces carbon dioxide. So what class of organic compound does the organic compound Y belong to? The answers from the chart, Madam Ruth, inakuja nini? No, of course, yeah, we can get there.
Alkanoic acid.
Yeah, that's correct. I think when you come on
Alkanoic acid.
Yes, and why react with the propanol to form a pleasant smelling compound Z? So what class of organic compound does Z belong to? Very fast. Z.
Ester.
Ester is okay.
Ester, they are saying it's an ester.
So very good. That is the answer. Now we can with the structures we cannot, but we can name. Let's look at the names. What are the name and draw the structural formula of compound? Where is compound Y now? Name and draw the structural formula of the compound Y. Yeah. That is now whatever. The name of compound Y will be called what from here? What is compound Y? The name is what?
From the charts, they are saying it's propanoic acid. Somebody's talking about ethanoic acid. Propanoic acid.
Students, I told you the trick. When you want to get the components of a polymer or and this an ester, unakuja unaikatanisha katikati. Ukikatanisha katikati, hii side iko na O. Who is that? Just Mr. Mulala, I think we can just mute anybody. Let me just unmute all of them.
You need to download.
There are some people who are not normal. When you are I'm just wondering.
Just continue.
Okay. Wherever you are given a combo like this an ester to get the component, unakuja unaikatia katikati. Mali kuna O unaikata katikati. This side contains the alcohol. So you just count the number of carbon atoms. 1, 2, 3. So this is propanol. But the Y was the acid. So the acid is on the left, on the left-hand side. You also count the number of carbon atoms. 1, 2, 3. So that becomes propanoic acid, not ethanoic. And remember, the carbon atoms unahesabu mpaka hii ya functional group. 1, 2, 3. Propanoic acid. So that's it. So that's the answers. The structure, the name is propanoic acid. The name is propanoic acid, and the structure ndio hiyo. It must be as open as possible vile unaona nimeichora. And of course, these are nimekuonyesha how to get it. From here, you get the alkanoic acid. From there, you get the alkanol. And you just count the number of carbon atoms. 1, 2, 3, propanol. 1, 2, 3, propanoic acid. So the name of that ester is propyl propanoate. This one is just showing you how to get the answer. I think there's a student from Homa Bay County.
There is a student. There is a student. Unmute and speak kindly.
Now, Lisa.
Yes.
What if the number of carbon atoms on the right hand side and the left hand side are not the same?
It's not like, sorry. We can even, hata hii ingekuwa hivi. What if it was like this? CH3. Assume hapa kulikuwa tu CH3. The idea is umekatanisha hapo katikati mahali O iko. So how many carbon atoms are on this side? The one that is forming the alkanol. Ngapi? The person from, there is how many? How many carbon atoms on this?
3.
1. Carbon atoms.
1.
1. So what is the alkanol?
Alkanoid.
The alkanol, the name of the alkanol is what?
Methanol.
What about if it was CH2, CH3?
Ethanol.
Methanoic.
Ingekuwa nini? Ethanol. Just like that.
Methanol.
Umeelewa sasa eh?
Ethanol.
somebody from Uyugi is it Uyugi Dama Siaya? Umeelewa?
Yes.
Yes, just like that. That is the
Thank you.
mechanism behind that. Okay, then we go to the types of polymerization. We have addition polymerization. This occurs when many unsaturated molecules combine to form a very large molecule of high relative molecular mass called a polymer. So addition polymerization is whereby many unsaturated molecules will combine to form a very large molecule by breaking up of the double bond. You can also have the issue of the breaking up of the double bonds. That is it. So many unsaturated, that word many unsaturated is very important when you're defining that. This is when many unsaturated molecules combine to form a very large high molecular mass molecule called a polymer. Just that is what we call the addition polymerization. It involves unsaturated molecules. So the presence of unsaturated molecules is what makes the polymerization possible, is what makes the polymerization possible. Very important for you to be able to capture that. When very many molecules, unsaturated molecules to form, combine to form a large molecule of high relative molecular mass called a polymer. There is no other product that is formed. There is no other product. There is no other product that is formed. There is no other product that is formed. Mnanipata kweli? Hello?
You are loud and clear, my friend.
Yes, sir. I'm asking like that because my Wi-Fi is not working very well, so I do. Sorry, just 1 minute.
Yeah, we can't hear you.
Yes, there's a Munsai Mnanipata. Are you getting me now?
Yes.
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 Sorry for that.
Yes.
There was some very cacamonious interference. And now we are okay. Now we continue and we look at, now we have defined polymerization and we have said it involves many unsaturated molecules combined to form a large molecule of high relative molecular mass called a polymer, and there is no other product that is formed. So the conditions for polymerization is high pressure and high temperature. So when you're told what are the conditions that are required for polymerization, is equal to high pressure and high temperature. But remember what I've said, that there is, in addition polymerization, there must be the molecules, or rather the monomers, must be unsaturated, and the product is just one, not two. I think that point is clear. That is something that you did in Form 3, in Form 1 and in Form 3. So examples of polymers formed through addition polymerization are as follows. We have there are 7 of them: polyethylene, polychloroethylene, that is PPC, polyvinyl chloride, what we call the polystyrene. We have the polypropene. We have the polytetrafluoroethene, which you call the Teflon. We also have the perspex, and then we have the rubber. So those are the 7 polymers that can be tested in an exam. Those are the polymers that can be tested in the exam. If somebody has raised the hand, can we see if there is anything that is that we need to talk about there? Any issue of concern?
James, kindly unmute and speak. James.
What about polyvinyl chloride?
Ndio hii inaitwa
Is it an additional
PVC.
polymer?
Hii ndio polyvinyl chloride, ndio hii. P for poly. The P is for poly. The V is for phenyl. Then C, fluoride. So polyvinyl chloride. That's what you could talk about polychloroethene. So polyvinyl chloride is what you call the PPC. It's the same thing. Unaelewa, eh?
Yeah, thanks.
Yeah, it's the same thing. Don't get confused. So naming addition polymers are named from the alkene, or rather monomer making the polymer, and adding the prefix poly before the name of the monomer. So kama uko na ethene, if the monomer is ethene, the polymer becomes polyethene. If the monomer is chloroethene, just like this. If the monomer is chloroethene, the polymer becomes polychloroethene. If the monomer is propene, the polymer becomes polypropene. That is how it is very simple to get that, except the perspex. The perspex now, the polymer is a little bit different. We have exception there. So that's it. And now we can look at, this one is just reviewing what you learned in Form 3. You need to revise too. Listen, students, this is ethene. During polymerization, this is exactly what happens. The double bond breaks. Sometimes the examiner can tell you this is a polyethene consisting of only 2 repeating units. So this is a section. This is not the general structure of the polyethene. This is the structure, a section, the structure of a section of polyethene consisting of how many monomers? Only 2. So hapa ni mbili, ya kwanza inakuja hivi. Una hii double bond, you break it to single bond. Then when you break it to single bond, that's what happens. So during polymerization, this is the polymer, this is the monomer. In your monomer like that. So what happens? The double bond breaks into a single bond. When it breaks to a single bond, we remain with hydrogen. Hydrogen. And then there is a free end on this side. This is what you call the repeating unit. This is what you call the repeating unit. So if you are told to draw, look at this thing. This is the monomer. During polymerization, the double bond breaks in a single bond. Then there are free end on both sides. And this now becomes the repeating unit. So when you are told to draw a polymer consisting of 2 repeating units, utachukua hii, tunaona ya kwanza, that's the first repeating unit, ndio hii. This one now, like this. Here. Then you repeat another one, like this. Then you just form 2. If you are told to draw a polymer consisting of 3 repeating units, you're just simply going to add another section like this on this side. Now, when you are now told to draw the structure of the polymer, you simply put this one into brackets. You put brackets here, like that. Then you write N. Then you simply write N, just like that. And that shows the structure of the what? That shows the structure of the polymer. So this is the general structure of the polymer. Minus the brackets, it becomes the repeating unit. If you're told to draw 2 or 3 repeating units, then you just repeat it, like kama ine ama tano, just like that. So this is what we mean. So this is the polymer. Ya kwanza, ya pili, plus other. This dot shows many monomers. So what happens? You convert this monomer into you convert from a double bond to a single bond. Then you draw the extension. This one is a radical. It has a free end that can join to another monomer. There's another free end that it can join to another monomer that side. Then you enclose and you put the symbol N. Look at the way I'm drawing. Hii kitu lazima enclose everything. Don't come here and draw something like this. A student will just come and draw something like this. This now will be categorically penalized. If you draw something like this, if you enclose like this, unaweka tu kitu kadogo hapa ka bracket hapa like that, that one will not score. So make sure that now, when you are drawing the structure of the monomer, the brackets are closing everything from marine to show that it is enclosing everything, the monomer. Then it should cut this point. This is the extension here, should cut it. Then you just draw the word N. It doesn't matter what you put it here. Hata hapa tukukuja tuweke.
Hello?
Yes?
You.
Yes?
18.
What is it?
Just
Now,
continue, Mr. Mbaluka.
Student, have you captured that point? This is a repeat of what you did in Form 3. Melewa?
Yes.
Yeah,
Yeah.
and just,
Yes.
and just,
sir.
yeah?
There is a student raising up hand, John from Wadi. He has been raising up her hand. Kindly allow her.
Kwa nini hizo lines zinapitanga kwa hizo brackets?
The one that, because that is
Speak
now
up
to
kindly.
show. Yes? What is it? Hello?
Just continue, Mr. Mbaluka.
Yeah, there is no particular thing,
Continue, Mr. Mbaluka.
but the brackets, we are saying the brackets should just cut through it. That to show that now it is enclosed. You know, it is an enclosure of something that is continuing. It's not, there are so many molecules, more than 1,000, more than 600. So you need just to measure that they are cut. But the most important thing is to measure that it is enclosing everything. Because if you the bracket, you just put it like this, it means it's only enclosing the carbon only, but not the hydrogen, which now makes the entire thing very wrong. So that's it. Kama mtu akona shida mingi zaidi, we'll be able to find a time. We may also review the others. But even if you are given, even if you are given a different one like propene, you just do the same. Open the brackets and then convert the double bond to single bond, and then you enclose, and you write the word what? N. If you're told to draw 2 repeating units or 3 repeating units, you just repeat three times. But if you're told to draw a section of the polymer consisting of 2 or more repeating units, you don't put a bracket now. You don't circle. If you are told to draw a section of polyethylene consisting of 2 repeating units, you don't put brackets. Because the brackets and the N is showing there are many monomers involved. But the examiner is very specific. He only wants you to show a section consisting of 2 repeating units, which you have already shown. So that one you don't put brackets. Let me remove this. So you don't put brackets. Then now we go to condensation polymers. So this condensation polymer is when many identical or different molecules combine to form a large molecule of high molecular mass with a lot of small molecules like water, even ammonia. The monomer should have functional groups at each end so that molecules can join at both ends to form long chains. So this one is very different, that you form a high molecular mass with lots of small molecules like what? Like water. And sometimes, in many times, you find there are different molecules. Mostly in addition polymerization, you are using identical. They are the same. They are the same molecules that are combined, like ethene molecules. But for condensation, it may be, in many times you're going to find different molecules combining to form the polymer. So though we can have talked about that, we are now need to look at the natural polymers. Natural polymers, they are found in living things such as plants and animals. These include cellulose, silk.
Kindly, Mr. Mbaluka.
Yes.
I can interject. There are two students who have been raising up their hand. There is Javi from State House Girls, and then there is Eric. Let us start with Eric. Eric. Okay. Jambi, kindly unmute and speak.
So I was asking, what if you're told to draw a structure of two repeating units, then you draw one unit, put brackets, and then instead of putting an N, you put 2.
No, that one is not. That now is compressing. That is now condensed structural formula. So that one will not school. If you are told to don't draw a structure like this, if you are told two repeating units, don't draw down like this. Who is that? That is Jambi.
Okay, continue. Continue. It was a guy called Eric.
Jambi unauliza hivi. Oh, it was Eric. I think
it was a student, Eric.
Mwenye ameuliza swali was a lady.
Yes, Jambi from State House.
Yes. Jambi ulikuwa unauliza kama umeambiwa 3 repeating units of polyethylene, unaandika hivi na unaweka 3. That is wrong. That is condensed.
Okay.
So you just make sure that you open it. Naelewana, usikuwe lazy kidogo, just be magnetic and just draw. Just repeat the 3 of them. So in that kind of a scenario, that you just draw the 3 of them repeating, just like that. Doesn't matter. And remember, even if you are given like when you talk about something like penethylene, like this one, assume now you have the examiner had given you this. This is hydrogen. Sorry, this one does not look magnetic. Sorry. So assume you have something like this. Just want to show you, these things are the simplest things that you need to know. So kuna double bond hapo, kuna double bond hapo. Hapo kuna C6H5. Hydrogen. And then the examiner tells you to draw the polymer for this is a penethylene. What would be the structure of that? You simply repeat. Una repeat tu hii kitu nimeandika hapa tu. From a double bond inakuwa nini? Single bond. Then you just repeat what is written here. Hapa kuna hydrogen, hivyo tu. Hapa kuna hydrogen. Hapa kuna hydrogen. Nini imeandikwa hapa? C what? 6. C6. H what? H5. Dash. Then we do what? Then we enclose like that. Then tunaweka nini? Sorry. Are you getting me? Mnanipata? Hello?
Yes.
So then you put N. Then you put N. Just like unaelewa.
Yes.
Don't be scared by the very complicated or rather scaring structure. Hata kama hujaiona hiyo kitu tangu uzaliwe, wewe tumia magic, tumia your superior powers. Copy that thing. Just convert the double bond to single bond. Then you do an extension of a radical extension, and close, put a head, period. And you have magnetically answered that particular question. Umeelewa? Sawa?
Yes.
Good.
Yes.
Now, natural
Yes.
polymers ni hizo. Cellulose, silk, rubber, protein, starch, glycogen, wool, fat, oil, wax, and sisal. According to the exam, ile kitu mimi nawafunza kupita mtihani. I'm not teaching you how to go and harvest oil in the forest. So, this is in terms of natural polymer, kama umeangalia mtihani from 1989. The only thing that you're going to be asked is name. Maybe an examiner can tell you to name two natural polymers, you know. Utashinda kusema kumesha at least rubber silk mbili. Especially this one, you just name. That's the only thing that you need to know. You need to understand the chemistry behind. Yes? Somebody was asking a question?
Pardon.
Nimesema, according to the exam, likely what you are likely going to be asked is to name. Like name two natural polymers, whereby you can just say starch, glycogen, wool, just naming. Normally, the requirement for the syllabus is for you to be able to name, not to explain how wax or sisal or silk is formed. Unaelewana, eh? Just simple, just know how to name them. Don't bother with the, I know the books zimewaonyesha mambo ya how to form proteins, but it's not going to be tested. So that one is not much going to be tested. So, but you can be asked, normally make sure that you are able to name at least 2-3 isomers. Then natural rubber. Natural rubber, it is special. Inakuanga special, kwa hivyo ni vizuri ni wafunze kidogo. Natural rubber is an addition natural polymer whose monomer is 2-methyl-butan-1,3-diene, which is called isoprene, with a structural formula as shown. This is is that a mutant or what? What? Somebody is making noise in class. So
I think there is a toddler there.
yeah, that must be somebody who is now. Now we go to natural rubber. Is a natural polymer, but it's an addition polymer. Very special in a way. I've never seen it being tested, the structure of it on how to make it, but it's good you understand because in many times it is highly used. So therefore, we may need to look at this is the structure of rubber. This is the structure of isoprene, or rather the 2-methyl-1,3-diene. 2-methyl-butan-1,3-diene. So in that kind of a scenario, I think this should be but, not butan. This should be but one. This should be simply but 1,3-diene, or rather isoprene. So this is the natural rubber. So being the natural rubber is very special. It's not like the others, and that's why it is not very much tested in an exam. So the real formation. So let me just give you, in case kuna mtu ataelewa na kuna mtu anataka kujua zaidi. In polymerization of this is not like the others. What happens is that only one double bond breaks there. Moja tu ndio ina break to a single bond. So this one of the double bond breaks into a single bond. So tuseme hii ime break. So this one breaks. This one is broken into, it breaks into a single bond. But when it breaks, the other one will shift to the center. So one of it breaks. Moja in a break. Don't know why it is there. Sorry. Where are we? Okay, good. So one of these, this one breaks. The double bond, this one will break. This one will break. But the other one will shift. In a shift to the center. In a kuja to the center. So that now the product has only one double bond. And any breakage of the double bond will create a free radicals on both sides. So whatever happens, just know that during polymerization of natural rubber, the monomer, if you are given it, only one double bond breaks. And the remaining double bond will shift iende katikati. Vile imetoka hapa inakuja katikati. Then you just repeat, you just copy that thing, you convert this one to a single bond, then you create a free end, and you bring the other double bond to the center. Now there you have your natural rubber. Understood, students? Mmeshika?
Yes.
Umeelewa?
No.
I repeat.
Hapana.
Ni repeat,
Yes.
tusikize vizuri.
Yes.
Nimesema hivi.
Repeat the one more last time.
The monomer iko na double bond mbili. During polymerization, only one of the double bond breaks, kama hii break. And remember, wherever a double bond breaks is going to create a free end on both sides. Unaelewana? Hiyo ni rule number 1. Just like the others. When the double bond breaks, now the opposite end there will be free end, free end. Are we together?
Yes.
That is point number 1.
Yes.
Point number 2, now the double bond yenye iko pale mwisho it shift position. It will shift its position from the far end to the center. Inaletwa katikati. So ndio maana unaona hapa double bond ilikuwa mwisho na mwisho, lakini sasa imekuwa katikati. And then now finally you have your natural rubber. Only one double bond breaks. And that is why after the double bond breaks, ndio maana tunakuwa na free end here. Tunakuwa na free end on this side. Then the other double bond breaks. The other double bond will shift its position to the center. Umeelewa sasa?
Yes.
Yes.
I have a
Sure.
question.
Yes.
Yes.
Uliza.
Can there be 2 double bonds after that breaking has taken place?
No, it can, because double bond is just 2. Na moja ina break. So we cannot have another 2 double bonds. Unaelewana? Umeshika?
Yes.
Yes.
Just like for the other, zile zingine zilikuanga tu na double bond moja. So ikibreak imebreak. Let me show you. Let me give you an analogy kwa sababu naona amuelewi. Let me give you a simple analogy. Let me stop the share. Mnaniona vizuri? Let me give you a practical, a pragmatic analogy.
Yes.
Assume umeshikana mkono na rafiki yako. Umeshikana mikono miwili hivi. Kama uko na mtu rafiki yako pale, unaweza fanya hivyo. Umeshika rafiki yako na amekushika, mmeshikana hivi mikono miwili hivi. Are you getting that sense, eh?
Yes.
Mko wawili, mmeshikana na the 2 hands. So that is like a double bond. Unaelewana?
Yes.
So now,
Yes.
ni kama sahi, for example, that kind of a scenario. Like even when you have 2 small sisters. But sasa useme kuna umeshika moja hivi na umemshika na mikono yote miwili. Na kukuwe na sistako mmoja mwingine mdogo pia na yeye anataka kushikwa. Si utaachilia mkono moja ndio ushike ule mwingine, isn't it?
Yes.
If I withdraw my one hand, si bado nitabaki nimekushika na mkono, nimeshika rafiki yangu na mkono moja. That it was initially a double bond. I've withdrawn my one hand. I'm still holding you. So I'm now having a single bond. Are we together?
Yes.
But now my hand becomes free. The other hand becomes free. Mwenye pia nilikuwa nimeshika pia inakuwa hivi. Kila mtu akona mikono on both ends, it is free. So we can join. Mwingine anaweza kuja, kama kuna wengine walikuwa wameshikana, wanaweza kuja washikane waende mpaka Mombasa. You can even make a polymer in school whereby you pair mko watu 50, mpe mkuwe 25 pairs wenye mmeshikana mikono miwili. Then you withdraw your one hand. When you withdraw with your one hand, it's like now you have converted a double bond into a single bond. But now your hand, the other hand becomes free. If there was another pair of 2 people that were also adding each other with 2 hands, that they break, they remain holding each other with 1 hand, and the chain can continue until possibly mfike huko mpaka mbinguni. You can even continue like that. That's the same essence of how a double bond is broken, is formed. That's how that is how polymerization happens. That is how polymerization will happen. So that's it. I think you have understood that. So natural rubber is hard and rigid when cold and is soft. And it is soft and sticky when warm. To improve on these physical properties, natural rubber is mixed with sulfur and heated to a temperature of 140. In a present called what? Hiyo mulisoma kwa sulfur and its compound. in a process called vulcanization. So the vulcanized rubber is less soft, tougher, and non-sticky and elastic. So that is the vulcanized rubber. So normal rubber ndio ile tunatumia ile kifuti tunatumia vitu kama hizo. But the same rubber ndio pia tunatumia kwa vehicle tire. So in that kind of a scenario, you find that now you cannot use the soft rubber yenye unatumia kufuta pia kuweka kwa tire ya gari because it's very soft. So in a way we harden the sulfur, we make it a little bit tougher through vulcanization. By heating it with sulfur, the temperature maintained at 140 degrees. So vulcanization of rubber involves heating rubber with sulfur. The sulfur atom forms links between the chains of rubber molecules, reducing the number of double bonds. This makes the vulcanized rubber tougher, less flexible, and less soft. So the science behind this is reducing the number of double bonds. So, and that is the science behind what you call now even the polymerization. So the double bonds that are present in the rubber, because you have seen the rubber contain the double bond. Once they react with sulfur, the number of double bonds are reduced. And this makes the rubber more tougher. It makes it less flexible and less soft. It makes it a little bit hard. So that's the concept of rubber, or rather vulcanization of rubber. You can take a screenshot. We continue.
Mr. Mbaluka, there is a student, Mr. Mbaluka?
Nakupata?
There is a student called Mike from Mombasa.
Yes.
Kindly unmute and ask your question if there is any question you want to ask. Mike from Mombasa.
Yeah, teacher, kindly repeat the screening. I need to screenshot. Repeat only.
Which part?
Repeat. Yeah, repeat the last ile sentence ya nini mbele kiasi ile tulisoma.
The previous, I think it's the previous slide.
Vulcanization rubber, the next.
Here,
nyuma yake.
Here, this one.
Yeah, no, and
this one.
The next. Yeah. Thank you. Okay, teacher,
now,
thank you.
Okay, uses of vulcanized rubber. Making floor tires, making shoes, making balls, e.g. footballs, making hose pipes, making rubber band for tying items. These are the vitu mnajua, tires za gari. So there is nothing here for me to explain. Sindio, just screenshot. I've meant the use is very magnetic, so just screenshot. It is just direct. There is nothing there to explain. Umepata screenshot, kila mtu amepata?
Yes.
These are things you have used. So not something that is critical. Twende sasa kwa condensation. Yes? Yes?
There is a student raising up his hand called Jeremy.
Yes. Jeremy Mochama.
I cannot see that page.
For the uses.
The page which the other student has explained of the rubber and the.
Which one? This one.
I think it is that.
So you want to screenshot? And I hope
just
you
a
have done.
Second.
Yeah? Yes.
I think he is through. He's through. The guy is through. The student is through.
Okay, uses of vulcanized rubber, I think everybody has done it. So we go to condensation polymers. Condensation polymer is the process whereby two or more small monomers join together to form a larger molecule by removal of simple or rather smaller molecules like by removal of smaller molecules like water or ammonia. Like water or ammonia. Condensation polymers acquire different name from the monomers because the two monomers are different. Because the two monomers are different. So that is the point that you need to look at. So the condensation polymers are found to have two small molecules, when two smaller molecules combine by removal of simple molecules like water, hydrochloric acid, or ammonia. Condensation polymers require different name from the monomers because the two different monomers are used. So listen very carefully. That in the exam you have seen so many things, but ile kitu tutaletewa pale is either going to be the one that you're going to be taught how to draw it. It's either going to be terylene or nylon 66. So you need to know how to draw terylene and how to draw nylon 66. How to draw terylene and how to draw nylon 66. So let me continue. So we start with nylon 66.
How to ask the examination?
This is exactly what I'm going to deal with. The condensation polymer that we are going to deal. The first one is we need a polyamide. The polyamide we deal here with is nylon 66. So that's the first polymer that you are going to be asked. So there are only two polymers, condensation polymers, that you're going to be asked, which is the nylon 66, which is the polyamide, and terylene. Nakuja kwa terylene. Let's first of all break down the nylon 66. So the nylon 66, we use this, the monomer is hexan 16 diamine. Hexan 16 diamine is drawn like this in a CH2. 6 of them. Naona vile imeandikwa. 6 of them. Hivyo tu, alafu sasa hapa kuna amine. Amine group inaandikwa hivi. Amine group is NH2. So it is hydrogen ndio hii hapa. Nitrogen, hydrogen, hydrogen. So that is what we call 1,6 because there are 6 carbon atoms. So this one is an hexan 1,6 diamine. Iko na amine group. Amine group ni hii. NH2 na ni mbili. Ndio maana tunaziita diamine. So there are 6 carbon atoms. So how do you draw it? How do you draw it? How do you draw it? 6H2. Angalia. Anyway, examiner atakuwa amekupea 6H2 mara 6. Then there is a amine group here and another amine group here. So that one becomes a diamine. But it is hexan because it has 6 carbon atoms. So that is the diamine. Hexan 1,6 diamine, meaning that the amine group, the NH2, is in the first carbon atom and the 6th carbon atom. Then we have hexan 1,6 dioic acid. Hii ni CH2,4. Najua watu wengine wanaweza shangaa, mbona hii, why is it that this one is C, why is it that this one is C, why is it that one is CH2 4 times, but the other one is CH2 6 times? Because of one thing. Remember, these are 4 carbon atoms plus this one plus this. Total, how many are they? Students, how many carbon atoms can you be able to see?
6.
Yes, so that's why we are still calling it hexan, because the other carbon atoms are here. And it has a carboxyl group on the first and the 6th carbon atom. Kama ungeanza kuhesabu 1, 2, 3, 4, 5, 6. So it becomes hexan 1,6 dioic acid. So how do you polymerize? This is the simplest thing. And let me tell you. Nikiuliza kwa ile mulisoma this is a polymerization, by the way. This is simply polymerization. So in polymerization, where does the hydrogen come from? From the acid or from the base? Ile polymer mulifanya huko nyuma. Where do you get the hydrogen and where do you get the OH?
Acid.
The hydrogen is generated from where?
Hydrogen from the
From the
OH
acid.
from the acid.
From the
OH
acid.
from the. What provides the hydroxyl, the OH? Kuna mtu ameongea na amesema vizuri. Simuandike kwa chat kama.
From the
OH comes from the acid.
The OH comes from the acid, correct. So what will happen here? Look here. Look here. Nini yangu ifanye? Here's a problem. I just want to show you what will happen. The amine will remove. Okay, let me show you. So kuna mahali unakimbia. Now we have the amine will donate the hydrogen, while the carboxyl group will donate the OH. So when this one combine, the hydrogen plus the OH will get what? Water. And because there are two of them, so this OH will combine with this to form a water molecule. And the other hydrogen will combine with the other hydroxyl group to form a water molecule. Whatever remains now combined, you can be able to see. Whatever remains here, this one now. Whatever remains here, inateremka hapa sasa. The first component. Look at this. Whatever remains here now, inateremka hapa. Now whatever remains on the other side, this one now, ndio inateremka on this side. And there you have your nylon 6,6. Why do you call it nylon 6,6? Because it's made up of two monomers, whereby each of them has 6 carbon atoms. That's why we call it nylon 6,6. And is used as a substitute for cotton in textile industry to make ropes, carpets, brushes, fishing nets, parakeets, etc., etc., etc.
Excuse.
Yes.
Pardon the way the nylon 6,6 is formed.
Okay, look here. Okay. Tuanze, the amines will donate the hydrogen. So hii itakuja hiyo hydrogen moja ndio hiyo. The other hydrogen. The two they are diamine. So each of the amine group will remove. The one that I'm circling with the red is showing you it is being removed. Are we together?
Yes.
Tunaelewa. Sasa tukitoa hivyo nini inabaki hapo? What remains here is what? Si ni sasa inabaki, si ndio? Inateremka hapo chini.
Yes.
Inateremka ndio hiyo sasa. Unaelewana? Sasa hii ndio inakuja hapa.
Yeah.
Na inakuwa na free end because tumetoa hydrogen. So inakuwa na free end. So chenye kinabaki nayo hii ingine inatoa the hydroxyl. Mnaona vile inaenda? This one now is the hydroxyl hapo, the hydroxyl hapo. Nini inabaki?
Hiyo ya hapo juu. Hiyo iko juu.
So now whatever remains, I'm trying to get whatever remains ndio hii sasa inateremka nayo inakuja hapa. Ndio hii sasa inakuja ina form this. Unaelewana? Nayo pia inabaki na free end. Then for every hydrogen and hydroxyl forms 1 mole of water. So you need 2 hydrogen, 2 hydroxyl, you get 2 moles of water. Then you enclose na unaweka head. Just like that. Umeshika? Yes. I can still repeat again in a more magnetic manner. These things are simple. Msione kama ni ngumu juu zinawatisha. Nilisema hivi.
There is a student raising up his hand. David Odhiambo.
Yes. Anasema nini? Sorry, there was some interference. Mnanipata? I repeat the question. Sikuwa namsikia. Hello, mnanipata?
Tunakupata vizuri but ulikuwa umepotea.
Yes, yes. So mtoto I repeat the question. Anauliza nini ama pia yeye amepotea? Can I repeat how to form this polymer? Again.
Just repeat for convenience.
Yes, so these I've now magnified the screen for that it can be said. Tumesema nataka mtoto mmoja akumbuke. Tumesema the amine will provide you with what? Itatolewa nini?
With the hydrogen.
Hydrogen.
Yes. Hydrogen ya kwanza ndio hiyo na hiyo ingine zinatolewa hydrogen mbili. Then from there I'm still having issues of network, but I think we are still able to get me. So the hexanoic acid will donate the hydroxyl. So the remaining component now combine to form the remaining component now, this one now, combine to form the first component of the polymer, which is this. Then we continue and we look at the other one. The dioic acid, whose component is that, the remaining component after giving the hydrogen combines to form this. And I think that is very clear now. Then the atom that will be removed from each of them, hydrogen, hydroxyl combine to form water. Melewa?
Yes.
Good. Can you continue? Sasa hii si mnaweza jifanyia tu. The one-side will give what?
Yes.
Sasa hapa kwa terelin. The one-2 will give what? What will it give? The OH ama the hydrogen.
Pardon?
Now we are combining now in terelin. We are combining hydroxyl than 1,2-diol.
We're OH.
Benzene 1,4-dioic acid. The than 1,2-diol will give the what?
The OH.
The OH.
And then benzoic acid.
The H.
The H.
Can you listen?
The OH.
Listen and listen very carefully. For all polymerization, despite there is some kind of fallacious misnomer, which is captured in the books, always the acid donates the hydroxyl, not the H. The OH will come from the alkano during polymerization. Tuko pamoja?
Yes.
Unaelewana?
Yes.
Yeah.
Get this now from there. Write it down that during polymerization, the hydroxyl group, the OH, that forms water, is donated, comes from the acid, not the alkali. Na tuko tumefika pale tumemaliza. The same scenario is here. Nimesema the hydroxyl group OH the OH comes from the acid, not the alkano. So juu ya hiyo story sasa, the ethan 1,2-diol itatolewa nini?
The hydrogen.
So angalia sasa.
The hydrogen.
Angalia. Let me acha nikupeleke pole pole using the magnetic explanation. Unaona? You see what I'm doing, eh? The alkano is, we are now removing the hydrogen. Then the acid inatolewa nini? The
The
OH.
OH.
The remaining components, the remaining component will do what? Tunaziona sasa?
You combine.
Tunaona vile inateremka hapa.
Yes.
Then you get your terylene. Hivyo tu. Tunaona ni rahisi sana. Sasa nakuuliza, ungesema utoe OH hapa, ungepata structure of terylene kweli?
Yes.
Ungepata?
Hapana.
Yeah, because sasa hapa ingeanza na C. And you should not start with C. You should start with an O. With an O. Tunaelewana eh?
Yes.
Yeah.
Najua hii ilikuwa inawasumbua sana. Umeelewa kabisa sasa? You can draw it even when you are sleeping, isn't it?
Yes.
That is the magnetism of understanding. Terylene is not captured in KLB. It is always tested in KCSE. So imetestiwa in fact mara tano. Terylene is not in the KCSE, it is not in the KLB, but it's usually tested in KCSE. So capture that one very clearly. You are going to get it. It is usually tested. The polymers zile zinatestiwa za condensation ni mambo ya terylene na nylon 66. Usiende kushida unasoma mpaka unapoteza kichwa ukisoma mambo ya vitu kama polymer, the structure of proteins, the structure of water, and all those kind of scenarios. This is exactly what you are likely going to see. Terylene is used in manufacture of safety screens. Don't say it's a substitute for glass. That one does not make sense. Talk about the manufacture of windscreen, safety screen, vitu kama hizo. So that's it. So those notes are from top-notch book 4. You're able to get them. So and that's it. You're able to get the structure of terylene polymer there. Then synthetic polymer, hizi tulikuwa tumeangia mambo yake. Synthetic polymer ndio hizo additions, hizo za polyethylene, polypropylene. So just take a screenshot. There is nothing to explain there. Hakuna kitu ya kuexplain hapo. There's the plastics. Aya, nime stop screen sharing. Sorry. Mnaiona? You able to see it?
Yeah.
Yeah, just screenshot. There is nothing that I'm explaining there. Hiyo data tulikuwa tumeongea mambo yake. What is it now? Nini yangu imekwama. Okay, good. So, uses of polymers. Pia screenshot. So, I just want to give you a warning. Ukiambiwa upeana use kama the polyethylene, usianze kusema manufacture of bottles. It should be plastic bottles, plastic water pipes, not water pipes. Because water pipes inaweza tengenezwa hata na metal. So tell us, the one that you're talking about here is the plastic water pipes. Kama ni polypropylene is used to make plastic threads, plastic carpets, not just manufacture of bottles, manufacture of whatever, should be plastic bottles. So those are the issues. Like aspects, ukiangalia kitabu yako imekuandikia manufacture a substitute for glass. Ushaona kitu kama hiyo? Hello? You have seen something like that, isn't it? That is a very general statement. So tell us, tell us what is that thing you are telling us, substitute. Tell us. Tell us, give us specific answer. It is a substitute for polythene. It is used as a, yeah? Kuna mtu anauliza swali. So nimesema kama ni perspex, don't say substitute for glass.
If you told,
tell us manufacture of windscreen, manufacture of material that can manufacture glasses, sunglasses, manufacture of boiling tube. Don't say manufacture of lab apparatus. Tell us one of the lab apparatus that can be used. And I think that will be very okay. So just take a screenshot of that. You need to raise it. Make sure that you're able to know the uses of each of them. Nimekupea polymers zote zenye inaweza iko kwa syllabus. So have you taken a screenshot of them? A summary?
Yes.
Yes.
Yes. And the strategies also take a screenshot?
Yes.
Advantages and disadvantages of synthetic polymers over natural polymers. They are lighter, they are stronger, they are less expensive, less affected by acids, alkalis, water, and air because they are plastics. Disadvantages are highly flammable. They don't decompose easily, meaning they bring about environmental pollution because these are plastic. And they give off poisonous fumes when burned. This is how you qualify your answer. You don't just say they give off poisonous gases. They give off poisonous gases when burned. Mashika?
Yes.
Yes, that's it. Study the structure of
Excuse me, sir, I
formula.
have a question.
Yes.
During manufacture of tires, raw rubber is heated with sulfur, carbon, phosphorus, and manganese. What's the name of the process?
That is vulcanization. Yeah, that's the main reagent there, that is sulfur, which is simply vulcanization process. And finally, that's the assignment. And maybe we have 5 minutes remaining. So I do take your assignment. I'll handle any burning issues. You can also give us feedback about the things. So I think we can be able to get that. As I told you, that we'll try to see if even if there's a kind of a lesson, I can also upload it in YouTube so that we can also be able to get from there. But you can get more of that. So that we have come to the end of our beautiful lesson today. So I'll now allow Mwalimu students. We can get any feedback from the learners, also from the teachers.
A question.
Yes.
A question.
Yes.
In the manufacture of nylon 66,
yes,
this product, water, now formation of water. You
are
wrote
saying
through
what?
N and then the water molecule.
And you are saying what?
The manufacture of nylon 66.
Yes.
Slide, I have a question.
Yes. Sipati, I think tumepoteza huyo mtoto.
So I'm saying you show the slide in the screen. I have a question.
I what? There are some people who want to.
Yeah.
I share the what? The screen.
Oh, the one with the manufacture, the formation of nylon 66.
Yes, what's it?
Yeah, there is this 2N and then the water molecule.
Yeah.
Where's this 2N coming from? The 2N.
Oh, good. You see, this N represents a combined molecule of both hexane 16 and hexane 16 diamide. Tunaelewana? This structure here, this structure tumeweka hapa ni the structure ya combined, when they combine together, the hexane 16 dioic and hexane 16 diamide. Tunaelewana? Are we together? First of all, there, this first structure that we have drawn here represents a combination of hexane 16
yes.
and hexane 1. That is what you call N. Tunaelewana? Umeshika hiyo point kwanza.
Yeah.
And then for every combination, how many moles of water are we producing?
2.
2.
So
if there are 20, if there is one molecule, you produce 2. So if there are 20, it will be 2 molecules of water times the number of monomers that are there. So the N is the number of monomers of the polymer. So the number of monomers of the polymer, the moles of water will be 2 times the number of monomers of the polymer. Unaelewana?
Yeah.
Umeshika sasa where the 2 comes from?
Yes.
Yes.
Thank you.
Very good. I think we are now through. Maybe tunamalizia. Kuna mtu ako na shida. Saa hiyo.
Labda yangu nimeweka huko.
Kuna mtoto nimeona anasema how to answer KCSE question. I think before we in Wednesday next week, I'll navigate through practical analysis. Yeah, practical. So I'll be able to give you the KCSE tips, what can be tested, what are the common mistakes, and maybe one of the days I can just organize a talk for chemistry, for both theory and practical, on what of the common mistakes, what is tested, and all those kind of things. That is some of the requests that we are seeing from the chat. Our next lesson, Mr. Mulala, I don't know. The next lesson, I think we can just have a revision. We can revise the.
Yes.
We can revise the organic chem.
Yes, yes.
Okay, that will be nice. That will be okay.
Yes.
Yeah. We can just have a question for revision. I'll be able to prepare one on Monday. Monday is a tricky day because that is when teachers are going back. We'll still try to see. So even if we reschedule the lesson to be late, I don't know whether the students will be able to. Yes?
Can we have a chemistry group?
Yeah.
A chemistry group.
WhatsApp group.
Yes.
Yeah, what's up?
I'll maybe we will organize with Mr. Mulala, then we'll be able to see what can be done. If that is okay. Provided you are not going to misbehave in the group. Can we get that assurance?
Yes.
Yes. So
Yes.
from there we
Yes.
You know,
those misbehave you can remove.
Yes.
Yes.
But no, there are others who will be there to behave like mutants. You know, they are allotropes of students and very magnetic students. But but I just hope you are very you are allotrope with a giant ionic structure, not a giant atomic, not
chemistry. Allotropes and magnets.
Not amorphous. You see, you know, we expect. Yeah, we are. Okay, I can be able to see the Machakos Mulingana school, and I can be able to see they are there. Wakona mwalimu hapo, is there a teacher in that Mulingana? That's good. I can see more than 30 students in Machakos Mulingana. That's very, very magnetic. Is there a teacher there in Machakos Mulingana High School whereby they can say something? Yeah. That's wonderful. We're able to see. Mr. Mulala, Madam Ruth, anything that we need to add?
Umerudi tena. Supuje. Hapa usiposha vyombo.
Mr. Baluka.
Yes.
I think I've created a WhatsApp group and I've sent the link to them. Those who want to join, I've sent the link.
You can just send the link here. Umeniongeza, have you added me to that? We can just send the copy paste the link in this. Make up.
I've done so. You can check in the chats there. There is a link which I've sent there.
Yeah, just me. I'm using a laptop, but students, just check the WhatsApp group that has been created by Mr. Mulala. The WhatsApp group that is there. Are you able to see it, students? So can you just join the WhatsApp group?
Kambaluka.
Yes.
And can you teacher if anything, yeah, the papers or the revision or the notes for the and kindly post us on the group, WhatsApp group. We're on we're on active on WhatsApp.
In Alliance School, including the exam that we have already done our mocks. I'll send everything there, and from there to be able to carry it. Even we can even schedule a meeting. Sometimes even sometimes in the evening, if we are not able to get some time.
Thank you.
So don't worry. Now that we have a group and Mwalimu has already created, Mr. Mulala, just add me direct because I'm using a laptop and not using my phone, so that I'm able to.
Let that group.
Excuse me, I have a question.
Yes.
You know. Thank you.
Excuse me, Mr. Mbaluka. I have a question. Bismuth chloride undergoes hydrolysis in water, resulting in the equilibrium. A white suspension persists because of hata sijui kusoma equation. So can I write for you in the chat box?
Let me just get I can easily get you the question. I know where it is. So don't worry. Because this is the ocean of chemistry you are talking.
Thank you.
I know what you want to ask. Sasa huyo ni nani tena? Ai. Some of these people are very cantankerous.
Tupigia kelele.
That's a very good person.
Yes.
Sir,
Yes.
can I ask?
Yes, uliza tu.
I'm using a laptop, so how can I join the WhatsApp group?
Use the
Okay.
WhatsApp web. Tumia WhatsApp web.
Yeah, just nafanya hivi copy your link and paste it somewhere. You can paste it even to your email. You can send it to your email, or you can paste it somewhere, then you can send it to your email. When you click it for email using your phone, you join the WhatsApp. Yeah. When you copy that link, it's one way of doing it. That lady who was asking about the new, I cannot be able to get properly that. The party on Neo, I'm a little bit. I'm not able to get that question, but I think I'll be able. Yes.
The question nauliza.
Yeah. Inauliza nini? Are you here? Ama nimetupwa nje?
Chess unajua equation venye kunaenda.
Let me just share. Nimeipata.
Hiyo
ndio swali. Ndio hiyo.
Okay.
Is that the question you are talking about? Ni hiyo.
Ni hiyo.
Sasa unauliza nini?
Yes, that one.
Or you just want the answer, eh?
Yes, ujibu.
Okay, good. So in this kind of a question that now.
And then you give me the reason for the.
I think I may need I'll also direct you to YouTube, to my channel, because I've analyzed this one, because you also need to understand more about equilibrium. Whatever is needed here is like now you're adding hydrochloric acid. So whatever you are given a question whereby there is a white precipitate, you answer the question in terms of more of the precipitate dissolves or more of the precipitate is formed. So what will happen when you add dilute hydrochloric acid? What will the equilibrium shift? Will it shift to the right or to the left according to you? Will it shift to the what?
Pardon?
When you add HCl, unaangalia HCl here. HCl ndio hii hapa. addition of any of the components involved in an equilibrium will shift the equilibrium toward the opposite direction. So when you add the HCl now, because it's in excess, will now shift the equilibrium to the left. And it shifts the equilibrium to the left. Now, more of the white precipitate dissolves because more addition of hydrochloric acid will shift the equilibrium to the left. Rather, the backward reaction is favored to reduce the excess HCl, just like that.
Mr. Mbaluka, excuse me, Mr. Mbaluka.
Yes.
Mr. Mbaluka.
So, Chair,
Nakupata.
what is the reason for the...
Please, we have eaten into the other lesson. Let's wind up and finish.
We are through. We are through.
The other group.
Okay, sir. Thank you. Pole.
Yes. Just wind up, eh?
Okay, we are through. So we.
The last one is sweet.
Okay. So goodbye to another Squingin and Estrik.
Goodbye.
Bye.
The best.
Mr. Mulala.
Goodbye.
Goodbye.